So this is the problem 34th of chapter 7 of Giancoli 6th edition. So what we have is an explosion that breaks an object into two pieces, one of which has 1.5 times the mass of the other. So I'm going to say that one of the objects has mass A and the other one that has mass mv 1.5 times ma. So A is the light one, that's my choice, and B is the heavy one. Okay, so after this explosion, these two objects move away from each other, and the other thing that we know is that a certain amount of energy was released, and this amount of energy is given to us. So in my case, this amount of energy is 74,000 joules. This is energy released. Okay, and then we have two questions. We want to know how much kinetic energy each piece acquired. So we want to know what is Ka prime and what is Kb prime. Okay? To solve this problem, I'm going to use conservation of moment. I have this whole object initially without any motion, without any momentum, and after the explosion, they break apart, and each piece acquires a certain momentum. And I'm also going to use conservation of energy, not kinetic energy. This is not any sort of elastic collision, but conservation of energy. So let me start using conservation of momentum. So conservation of momentum, we know that we just need to write MAVA plus MBVB. No motion initially, this whole object is a single one, not moving, 0. After the explosion, the two pieces break apart and move away with speed VA prime and speed VB prime. So from this relation, I can find an expression for a relationship between the two speeds because I know the relationship between the masses. So I'm going to substitute this here. I have 0 equals to ma va prime, and mb we said that is 1/2, or we can also write as 3 halves, right, of ma vb prime. So from here, I found the relationship that I said. VB prime is minus 2/3 of VA prime. I do not know exactly what this value is, but I have this relationship that may be useful for us later. Okay, now let me use conservation of momentum to try to find an expression for the kinetic energies. So, conservation of energy tells us that the initial energy, the initial that was added to the system to burn, to break the system, whatever kind of energy there was, chemical energy. So this amount of energy that was added to the system, and this amount of energy is this one, is this 7500. So this initial energy is equal to the final energy. This amount of energy that was added so that these two pieces could break apart, in my case, is 7400 joules. And this is what gives the momentum. This is what gives the speed. This is to the two masses. So this total energy will be transferred into kinetic energy, Ka prime plus Kb prime. Okay. All right. So what I want to find, Ka prime and Kb prime. So I have these two unknowns here. Let's try to manipulate these equations a little bit. Let's remember that I have this expression, I have this relationship between the two speeds, and I also have this relationship between the two masses. Okay, so let's write what is the kinetic energy for each piece. So 7400 joules is equal to 1/2 of ma VA prime square. This is the kinetic energy of particle A. And for particle B, I have 1/2 of mb and vb prime squared. But I also know, and I'm going to use this here, I also know that mb is 3/2 of ma. And I also know, I have found that above, that vb prime is minus 2/3 of va prime. So you see that what I did here, I wrote this whole equation now only in terms of mass A and VA prime. So with this, I can rearrange the equation and write it just for the kinetic energy of the particle A. So what I mean by that is I can write this equation as 7500 is equal to, this whole thing is the Ka prime, right? So 1/2 of ma va prime squared is the Ka prime. And I also have 3/2, this part here. I also have minus 2/3 square, which is this part here. And what remains? 1/2 of ma va prime squared. So you see what I did? This is the kinetic energy of particle A, and this is also the kinetic energy of particle A. So I wrote this equation only in terms of the kinetic energy of particle A. And so now we can find what this value is. My only unknown now is this Ka prime, which is the kinetic energy of particle A. So I have 1 coming from this term, and from the other side I have plus 3/2 of 4/9. Okay? So this whole thing here is 1 plus 2/3, which give us 5/3. So we can now find Ka prime. Once I have Ka prime, I know that I can also find Kb prime, since the sum of Ka prime plus Kb prime is what gives us the initial energy, the energy that was added to the system to cause this explosion.